Hello everyone, welcome to the Click Physics 1 course. Today we will begin Chapter 3, Reflection of Light. And in this lesson we will learn what light is, the different types of light rays, sources of light, the properties of light, and reflection and its laws. So, first of all, what is light? Light is a form of energy that enables us to see the objects around us, and according to the definitions, light emitted from luminous objects reaches our eyes, and therefore we are able to see things, and without light our surroundings would appear dark. For example, imagine entering a room at night without turning on a lamp. It becomes difficult to see anything. And common sources of light includes the sun, candles, lamps, and flashlights. Therefore, we can say that light plays an essential role in our daily lives. Light rays. Let us discuss light rays. A light ray is represented by a line with an arrow, as you can see in here. The arrow indicates the direction in which light travels. Light rays are classified into three types. And the first one is the parallel rays. These rays never meet each other and always remain the same distances apart. Second, converging rays. These rays, as you can see, they move towards one another and become closer together until they collide. And third, diverging rays. These rays spread apart as they travel, as you can see in here. And these three types of ray help us understand how light behaves in different situations and optical devices. Okay, here we have sources of light. Well, objects are divided into two categories: luminous and non-luminous. Luminous objects are objects that produce their own light. Examples include sun, candle, flashlights, etc. And it is then after that we have non-luminous objects, and non-luminous objects, on the other hand, do not produce light. And the examples include books, stone, chair, and etc. And it is important to remember that we can see non-luminous objects because they reflect light from another source into our eyes. Okay, so here we have speed and properties of light. Light has the highest speed found in nature, and as the definition states, the speed of light in a vacuum is approximately 3 times 10 to the power of 8 meters per second, or we can say 300 million meters per second. And light possesses several important properties. It can travel from one place to another and reflect from the surfaces and refract when entering a different medium and disperse into colors, which can be any kind of colors. And these properties make light one of the most fascinating subjects in physics. Okay, we will now discuss the main topic of this chapter, which is reflection of light. Reflection occurs when light strikes the surface of an object and returns to the original medium, or bounces back. And to understand reflection, we must become familiar with the following terms in here: the incident ray, which is the incoming ray of light; the reflected ray, which is the ray that bounces back. The normal line is an imaginary line drawn perpendicular to the surface. And we have angle of incidence, which is the angle between the incident ray and the normal ray. And we have the angle of reflection, which is the angle between the reflected ray and a normal line. And these terms are very important because they are used in the laws of reflection. Here we have types of reflection. Reflection occurs in two forms, as we can see it in here: regular reflection and irregular reflection. Regular reflection, as you can see, takes place on a smooth surface, such as mirrors. And in this case, as you can see, parallel rays remain parallel after reflection, producing clear images. And on the other hand, we have irregular refraction, which occurs on rough surfaces. The reflected rays scatter in different directions, and although the light scatters, the law of the reflection are still obeyed at every point of the surface. And this is why we can clearly see ourselves in the mirror but not on a rough wall. Okay, laws of reflection. Reflection of light follows two important laws. And the first law states that the incident ray, the reflected ray, and the normal line all lie in the same plane. And the second law states that the angle of the incidence is equal to the angle of reflection. And we write this relationship as angle of incidence equals angle of reflection, or um, I equals R. And for example, if the angle of incidence is 40 degrees, then the angle of reflection is also 40 degrees. And similarly, if a ray of light strikes a surface perpendicularly, both angles are 0 degrees, and the ray reflects back along the same path. And these laws apply to all reflecting surfaces, whether they are smooth or rough. It applies to all. And here we are done with today's lesson. Thank you for watching.